In this lesson, we're going to be looking at an application of similarity and proportionality. So these are probably going to be very similar to word problems you did when you learned proportion, so hopefully pretty familiar and straightforward. So two vocabulary words we want to go over before we do this. One is indirect measurement. So indirect measurement is any method that uses formulas, similar figures, or proportions to measure an object. So it can be a combination of things. It could be one or another. Okay? And to use indirect measurement, we need what's called scale. And scale is that ratio of any length in a scale drawing to the corresponding actual length, which we've been calling the similarity ratio. So they're pretty much interchangeable. Okay? So we're just going to do a series of examples, and then we're going to talk about perimeter and area to round out our notes. So let's take a look at example 1. Tyler wants to find the height of a telephone pole. He measures the pole's shadow and his own shadow, and then he made a diagram. Then we're going to look for h, the height of the pole. So if you notice these measurements down here, this 5 foot 9 inches, 7 foot 8 inches, etc., you'll remember that we don't want to work with two different units in one problem. We're going to want to convert everything. So let's convert it either all to feet or inches, whatever is easiest for you.
Alright, so now that I've gotten my conversions out of the way, I can move on with the problem. But as a side note, the reason why I chose inches, remember 12 inches to 1 foot, if I divided all the inches into feet, I end up with decimals, and personally I don't like working with decimals, so I went with the larger numbers, which would be whole, which was the inches. So you can choose between inches and feet. It's up to you. Okay? So next, in order to use the proportions to figure out the scale, figure out the height of the pole, here's where we have to look carefully at the problem. I'm not given a scale. I'm not given the idea that these were drawn to scale. I'm not given anything about similarity. So this is a tricky one where I actually have to show similarity first. So the first order of business is show triangle ABC is similar to triangle FHG. In order to do that, we want to remember the sun's rays are so far away from us, so when light comes down, we're going to assume the sun's rays are parallel. So if you look at your diagram, imagine you being outside, right, and sun's coming down, casting shadows on everything. The light from the sun, that trajectory, that line would be parallel in all cases here, because we're assuming that it's just so far away, they come down parallel. So what would those be? Those would be FH and AC. So we're going to assume those are parallel. So this should make our life pretty simple to show that the triangles are similar, excuse me. So first I know that angle B is congruent to angle G because of the right angle congruence theorem. And then secondly, since these rays are parallel, I've got these lovely corresponding angles. That should also be congruent. So angle A would be congruent to angle F because of my corresponding angles postulate. And that conveniently gives me angle-angle similarity. Remember, when in doubt, prove them similar, and we're good to go. So again, it's because I didn't see keywords like scale, model, similar in the problem. If I saw those, I wouldn't bother with that first step. Okay? So once I show that they're similar, I can now set up my proportion to solve. So when you're setting up your proportion, you've got a number of options, but remember, you want to put corresponding parts in the same position. So for example, if I'm going to start off by looking at the side AB down here, I want to make sure I'm corresponding that with FG because that's, again, in the same position. They're both on the bottom. So that means I could put them together if I want. So I can say AB over FG because they're corresponding parts. And then because I went small triangle to big triangle, I want to make sure I do the same with the other given sections. So now I'm looking at the heights, which are CB and HG, and I want to make sure I'm putting that in the same positions in my proportion. So again, small to big, so CB on top and HG on the bottom. Okay? Then plug in your numbers and solve your proportion like we've been practicing. Remember to use your converted numbers. Alright, so then I just did the cross multiplication, and plugged everything in. Remember, this is only one way to set up the proportion. There's more than one. And then doing all that work, I should get height is 345 inches. Since the problem didn't specify if I want my answer in inches or feet, feel free to leave it in inches. But again, if you solved it for feet, you could also write your answer in feet. Remember, don't round unless specified. Oops. So here we go. It would be 28.75 feet if you converted, right? And you convert by dividing by 12. Okay, next, example 2. You can go ahead and read that. And we're looking at a roadmap, right? And this keyword scale tells me we've got a model. So I'm not going to need to show similarity here because I know we're looking at scales. We're looking at something that's already been measured out. Okay, so what I want to look at is I want to look at the ratio that's given, right? The scale 1 to 13. And then figure out the actual distance from Madison to LaSalle and to the nearest mile. Okay, so what you want to do is set up your scale, right? 1 over 13 as a fraction. And then you want to, again, make sure things are aligned correctly. So 1 stood for inches and 13 stood for miles. So I want everything to be this inches over miles. Okay, so if I look at what else I'm given 11 and 1/8 inches, so that goes on top. And I'm looking for the distance, which I call x or d, whatever you want, and that's going to be in miles, right? Because I want to find the nearest mile, so it needs to come down below. And then cross multiply. Remember, if it helps to convert your fraction into a mixed number, feel free to do that, right? But then I'm just going to get d is equal to whatever 13 times 11 and 1/8 is. And since I want it to the nearest mile, I'm going to round. So this is an example in the problem where it tells you to round, right? So if you just did that multiplication in your calculator, we get approximately 145 miles. Please make sure you're labeling your answers with the units because it has context in the word problem, so we want to make sure we answer with those units. That'll be important when you talk about area, perimeter, and stuff later. Okay? Example 3, Lady Liberty, which is another way of saying Statue of Liberty, right? We're talking about her this time. Read through the problem and let's solve this problem, okay? So again, look at the vocabulary. I'm giving you this word scale. So we already know it's going to be similar because if you're doing a scale drawing, you're adhering to a certain similarity ratio, which we're given right here, okay? We want to go ahead and find the dimensions of Lady Liberty's tablet to the nearest tenth. So we're going to pretty much do this in the exact same way we did that first one, but the only difference is because we need to find each dimension, so we need to do 2 proportions. Why don't you go ahead and try working through the length first, right? Because we need to find the length and the width, 2 different numbers, 2 different proportions. Okay, so check how you set up your proportion. If you're using a proportion, you want to, again, make it consistent. I went centimeters over meters, so that's how I set up my proportion. This is also one where you don't have to use a proportion because it's 1 to 0.75, so you could have also just divided, but again, it's what you know, right? And since I want to round to the nearest tenth, let's do that math work, and we should get the length being approximately 9.6 centimeters. All right, now go forth and do the width for me, please. Did you get 5.5? Hopefully you did because, again, it was pretty much the exact same thing, but now we were looking for the width, so we want to make sure we use the correct measurement. So make sure you read those directions carefully in the word problem so you know what you're using, right? 7.9 was the length and 4.14 was the width, and then you should be solid.